Good morning, everyone. Thanks for attending this Azure Disaster Recovery webinar. My name is Gary Jensen, Principal Consultant at SILVERSANDS. In today's session, we'll be covering the importance of disaster recovery and how Microsoft Cloud Solutions can help. We'll have a brief overview and demo of the technology, and then I'll finish up with some licensing considerations before we summarize the session. We aim to finish by 11:20, 11:25, and we'll be around at the end for a Q&A, so please submit any questions via the Q&A interface. The webinar will be recorded and you'll receive a link by email after the session. Okay, so as a business, you are delivering services to customers and end users, and I'm sure that everyone puts a great deal of importance on maintaining these services and preventing downtime. If you do suffer an outage though, there could be a number of impacts, including financial or sales penalties, brand damage, legal or regulatory action, or even job losses. Clearly all outcomes that are ideally avoided. To protect your data and service provision then, there are three core capabilities that you typically need to implement or consider. First of these is backup, a very typical requirement to protect your data, to allow restores in the event of individual hardware failure, file deletion or corruption, and to protect against ransomware and similar attacks. Then we've got high availability, which protects your primary and critical services against downtime caused by individual or short-term hardware failures. This might include your e-commerce systems, public websites, ERP, financial, and other critical business applications. Neither of these solutions, however, will protect you in the event of a massive infrastructure outage or complete data center failure. At this point, you will need to have some element of disaster recovery solution and processes to recover to a working business state. And this is what we're going to concentrate on in this webinar. So although we know that impact of an outage can be very damaging, implementing disaster recovery has historically been challenging with the additional requirements and costs of hardware, secondary data centers and/or third-party services. Testing has been particularly painful, with IT resources perhaps sent to a DR location for a week with hundreds of tapes, perhaps only able to complete a partial recovery, and or services not being tested to their full operational capability because it's simply too difficult. In an actual DR invocation, it may take a long time to get services up and running. It's quite likely that not every production service will be available in that situation. In some cases, organizations may end up not having any DR capabilities and may rely on a best endeavors approach in the event that a failure situation occurs. So the Microsoft services that support disaster recovery are the infrastructure as a service elements of the Azure Cloud Platform, together with the Azure Site Recovery Service. These capabilities and services can help by reducing the challenges of cost and complexity while supporting any compliance or regulatory requirements. So with Azure, there is no need to purchase additional hardware or sites. You simply pay for what you use when you need it. There are no long procurement cycles or builds. You simply turn on the services you need, so you'll be able to get going very quickly. Testing is simplified because you can fail over into a test state without any production downtime or impact. And because Azure delivers business continuity as a service, there is no need to patch, manage, or upgrade the software itself. From a compliance point of view, Azure supports many certifications, such as ISO 27018, which ensure you can build whichever services and applications you need. It enables more applications to be available in a DR situation and allows you to comply with your governance, audit, or insurance requirements. So let's have a closer look at site recovery, what it is and what it offers. So many of you no doubt will be familiar with Azure and its numerous capabilities, but for those that might not be quite so familiar, the table on the screen gives an idea of the platform and the services that it delivers today. The focus of this webinar is the Azure Site Recovery, which is the Microsoft DR Cloud offering, but in fact Site Recovery utilizes and integrates many of the Azure compute networking and storage components when facilitating the failover to the cloud. So what does site recovery do? So it will allow you to protect machines running in your on-premises virtual environments. So that's Hyper-V, which could be a single Hyper-V machine or a clustered Hyper-V environment, or one that's managed by Virtual Machine Manager. In a similar way, it allows you to protect machines running in a VMware environment, again on the standalone host or being managed by vCenter. And you can also protect physical machines, As well as on-premises machines, it's also possible to protect machines running in Azure. So you can do an Azure to Azure recovery, or even another cloud such as AWS. The replicated machines sit dormant in the recovery vault, where you pay for the cloud storage in a normal BAU situation and a nominal cost per instance protected. In addition to the cloud, it's possible to leverage your current DR facilities. So if you have on-premises DR site, you can use Azure Site Recovery to manage your VMM to VMM failover, or even your VMware to VMware failover. And it protects both Windows and Linux machines. Site recovery provides replication frequency as low as 30 seconds for Hyper-V and continuous replication for VMware. Machines are replicated using application consistent snapshots for single or multi-tier apps. And you can use site recovery to protect SQL Server backend workloads. It has a native support for SQL Server Always On, to manage availability groups, or to manage domain replication as well. So you can integrate all of these different services into the site recovery. Site recovery and Azure together simplify the application network requirements, including reserving IP addresses, configuring load balancers, and integrating global traffic management, such as the Azure Traffic Manager, to support efficient network switchovers. You can easily run test failovers to support disaster recovery drills without affecting ongoing replication or production services. This is quite an important factor, as it's very difficult to achieve ordinarily with legacy DR solutions. You can customize and sequence failover and recovery of multi-tier applications on multiple VMs with a recovery plan, or multiple recovery plans. You group machines together within the plan, add scripts and manual actions, and any automation to complete a seamless failover. And as a final benefit, it's possible to take an on-demand copy of the data being protected by Azure and stand it up in a test or development environment, which gives you a machine which is identical to that of the production machine, but isolated on its own network. At this point, I'm just going to step in to do a quick demo just to show you briefly how easy it is to replicate machines and fail them over into Azure. So here we have a standalone Hyper-V server, and we have two machines here, O1 and O2. O1 is already protected by Azure. We can see that in the replication pane here, and we can see when it was last replicated. O2 is not currently protected. So if we go into the Azure portal, so naturally we've already connected Azure to the Hyper-V server here as a prerequisite for this demo. And what we can see here is we've got a dashboard which shows us the health of our replication, and we can see we've got one healthy machine here. I'll click on that. So we can see that Server 01 is a healthy, replicated, protected machine. We also have a recovery plan configured here. Which we've configured just with one manual step, just to show you what happens when we have a recovery plan in place. But before I show you that, I'm just going to replicate the replicate server 02. So we start here. It already knows about the Hyper-V machine that we've got. We configure the target. So again, all this information has been recorded by the system. I just need to select a network here. Select the machine which it's found. Tell it what operating system is running. Apply the replication policy, which dictates how often it will synchronize, etc. And then we enable replication. And that's pretty much it. And we'll come back to that in a minute. We can see here that that's protection is being enabled. So while waiting for that, we'll just do a test failover. So if I go down to the recovery plan, and I can do a test failover here. At this point, I can choose various different options. The quickest option, which has the lowest recovery point, or the latest processed option, which is the lowest RTO. So we'll just choose that one. We have to attach it to a network. And again, that's now in action. So as I mentioned earlier, there's a manual step for this recovery plan, because in a real DR situation, there may be manual things that you need to attend to before you can actually continue the recovery of the machines. So if I open this one up here, open the details, and we can see here that we have to confirm with Dave Jones that we've got authority to continue. And I should be able to complete this action. Which I can't see at the moment. Okay, I'm not quite sure how to complete that action this time, so I'll come back to that. So if we go back to the ASR, and we can now see that we've got two healthy machines which are replicated. So sorry, I couldn't complete the test failover there, but that would complete, and then that machine would be up and running in Azure. We could then check that it's working without affecting the production network. And then once we're happy with that, we can finish the test failover, and the protection will carry on for future DR requirements. Okay, so just return to the slides. So I'm sure you'll agree that looks pretty straightforward, although it's obviously a very simple scenario, and business DR would need considerable planning to ensure, for example, that machines came up in the right order, that wait for specific services to be available, such as SQL, and so on. All of this is possible with ASR. So before I summarize what we've talked about today, I just wanted to cover off some important licensing considerations. So the primary requirement to support all of this is software assurance. So this enables you the right to run application machines in Azure data centers. And with this comes the disaster recovery right. And this is what enables DR protection, testing, failover, and failback. So this is only available with software assurance. It's not something you can buy independently. And it's only valid when you're using Azure Site Recovery. So this is a key factor. So if you're using an alternate product, then what you might find is that you're not licensed for DR testing. You can fail over to DR, but you can't fail back within 90 days. So typically for a DR situation, you may find that everything's resolved within a few days or a week or so, and you may want to fail back. But without ASR, without the disaster recovery right, you can't do that technically, and you'd have to stay in DR for the full 90 days. With ASR, you can do all the testing you want, you can fail over to DR, and you can fail back within that 90-day period. So as I mentioned previously, ASR is licensed per protected node. So you pay a monthly fee, and then you pay your storage costs on top of that for actually storing the machine, but you don't pay any running costs in the BAU mode, in the business as usual mode. So when you're in DR, you'll recover machines, and then they start to incur standard Azure charges. So it's only at that point that you pay the full cost of Azure. So to summarize, we know that DR protection is a requirement, but it can be hard, complex, costly, and difficult to invoke. Azure Site Recovery is a simple and effective solution to provide disaster recovery protection for Hyper-V, VMware, or physical Windows and Linux machines. Software assurance and ASR are the key enabling requirements, with full machine running costs only applicable during a DR invocation. So potentially a very cost-effective way of delivering your DR services. So we think this is a great solution for DR protection, particularly for those customers that have found it very difficult to achieve before. But before we come to the Q&A, I'd just like to thank you for attending today and ask you to please complete the survey that will be emailed to you afterwards. Also, just to notify you that there is an option for a free half-day consultancy engagement if you'd like to talk about this further with us. Otherwise, if you'd like to know more, then please feel free to contact us through the website. So at this point, we'll just take a few questions, and I'll bring in my colleague, Michael Kutanch here, who will potentially help us with any questions. Are you there, Mike?
I am. Hello, everyone.
Hi. So we've got a question here about ASR, whether it can do anything other than just DR.
Yeah, well, as well as DR, we tend to use ASR as a great kind of onboarding or migration tool. Obviously, as you kind of showed in the demo, we can do sort of test failovers of machines into Azure, make sure they work as expected. They can either be rolled back at that point or obviously left in Azure and sort of continue running. So for a lift and shift kind of sort of operation, then it works really well for that. So obviously in an ideal world, we would look to kind of either build fresh or re-architect a platform in Azure. Obviously sometimes perhaps that's not possible. Perhaps the way the sort of virtual machine or application is configured is unknown. Those kinds of things, or perhaps there's a kind of necessity to move very quickly to the cloud, whether it be perhaps data centers being sort of moved or lost. We can lift those machines to the cloud and then have them running quite quickly and look to re-architect that at a later date. As well as migration tool, as I kind of sort of touched on, it's also great for testing patches, those kinds of things on kind of live systems or true clones of what you might have on-prem without actually impacting those live systems.
That's great, thanks. Do we need any additional infrastructure?
So for Hyper-V, we don't. There are a couple of agents that are actually installed on the Hyper-V hosts or on the virtual machine manager host, depending on what you actually have on-prem. If you're running VMware on-prem, then there is an additional virtual machine and management server that kind of deals with the replication and how the service is actually configured. But again, that could be a virtual machine running within the VMware environment itself.
Okay, thanks. And what about any special network configuration?
There isn't anything particular that you need. You can actually replicate directly over your internet connection. Obviously, the kind of sort of if you were to fail over to virtual machines running in Azure as part of a true DR, then there would need to be a VPN or a similar kind of connection to the cloud, maybe a express route in the case of Azure, so like an MPLS line. For kind of just replicating to Azure, you can, like I say, do that over your standard internet connection, doing test failovers. That's not a problem. It's purely for when you actually do the switch over and redirect traffic for sort of live services up to the cloud that you'd need that VPN or equivalent in place.
Okay, that's great. And what about application support? Is there any particular requirements for applications that you're protecting?
So long as Azure supports the OS that you're looking to fail over from an OS perspective, then you're covered. Basically, if the OS runs on VMware or Hyper-V, then it's supported in Azure. From an application perspective, it's a case of speaking to the third party to make sure that it's supported running in the cloud. The main kind of issues or things to bear in mind when you fail over to Azure, whether it's kind of supported for connecting back to any services back on-prem, or if you're looking to go HA when you move to the cloud for an application that isn't on-prem, whether that application supports it.
Okay, thanks, that's great. And in a failover situation, how quickly would applications be back up and running?
I think that's kind of the million-dollar question, really. It does really depend on the size of the application, the number of virtual machines, whether it's a single box that's spinning up in Azure, whether, because of the way the recovery plans work, whether they're checking for other replication technologies to have failed over data. So, for example, in a kind of classic three-tier application, Azure Site Recovery can check that domain controllers are replicating correctly using Active Directory services and making sure that they're up. It could then double check and make sure that the SQL box has failed over using maybe sort of always on or availability groups. And finally, then once those are up, it will then power up the virtual machines, there may be web front ends, those kinds of things. So it really kind of depends, obviously, whether you're failing over a single machine, a kind of multi-machine application, or whether you're looking to sort of fail over a full data center. But typically a machine would be up within sort of just under 10 minutes for a standalone machine.
So it's quite reasonable to consider you could have a fair part of your core infrastructure up and running within a few hours.
Exactly, yeah. Obviously, depending on the platform and how it's architected, whether you're looking at ASR to fail over your domain controllers or whether you have domain controllers already running in the cloud and they're replicating already, depends really. But within the space of probably an hour, you could have a fairly complex sort of three-tier application running in the cloud and failed over.
Yeah, that's excellent. And you would use your recovery plans to orchestrate the order of recovery, for example, because you might have, say, applications which require a SQL server to be up before they themselves come up and that kind of thing.
Yeah, so ASR supports SQL Server. So if you have a standalone SQL box, it can replicate the whole of that SQL Server over, keep the disk consistent, and that sort of SQL Server will sat sort of dormant in the Azure Site Recovery Vault until such a time that it needs to fail over, and then ASR will sort of step through the workbook and essentially power up and check services are online in a particular order that's predefined. Or, as you mentioned, it will actually check and work alongside other kind of replication technologies, kind of any in-app replication technologies, so things like Active Directory, SQL, those kinds of things. We can use those replication technologies to replica data to the cloud. Site Recovery sits above that. We'll step through the processes to make sure all those services are online first, powers up any that it's managing replication of before finally failing over the service.
Excellent. Okay. And I think final question, how would users connect to an application once it's running in DR mode? So they're on-premises normally, and they've DR'd their systems into Azure. What's the connectivity requirements at that point?
Okay, so as mentioned earlier, something like a VPN or an express route connection, which is an MPLS line essentially. As long as that's in place, then from an end user perspective, if they're still on site, they'll be connecting the same as normal. Generally, as services fail over to the cloud, they'll update DNS as part of the kind of failover process. we can sort of add other things in there. So traffic manager, kind of global load balancers, those kinds of things to kind of manage any kind of DNS failover, or just if it's on-prem DNS, then obviously update DNS entries dynamically. So from an end user perspective, if they're on-prem, they connect in exactly the same way. Externally, if they want to connect, then we can have a look at that point to find out whether those applications are, if it's possible to actually externally publish them. By default, they won't be. They'll be on-prem. It's just an extension of your data center, essentially another site.
Okay, that's great. So we've got no other questions. So I think that's all great. We'll close the session there. So once again, thanks for attending, and we hope to see you again in the future. Goodbye.